Hello students, welcome to this video tutorial on Geometric Concepts Note Part 2. So let's continue on with our vocabulary, okay? So the first page was hopefully a review, and as we go on to the second page, we kind of get more into grade 7 geometric concepts. Alright, so let's start with parallel lines. So parallel lines are two lines that never intersect and stay the same distance apart. So they are two lines that never intersect and stay the same distance apart. So let's draw a diagram of that. So here we have two parallel lines. Now, you notice that one line is called NO and the other line is called PQ. Now, as you're drawing these lines, make sure you've got the arrowheads on both, but the most important symbol happens in the middle of the line, and that is this kind of arrowhead. Now, these matching arrowheads show that these lines are parallel. So please take your time in drawing these diagrams. Again, preferably with a ruler. Okay, so let's make some notes here. So we have line NO and line PQ are parallel. Line NO and line PQ are parallel. So there's a very cool symbol to show parallel lines. So NO and PQ, to show that they are parallel, we draw two vertical lines. Now we have to make sure that we don't confuse this symbol with the number 11. Okay, so I'm going to highlight it here because that's what I want you to remember. That symbol means parallel lines. Line NO is parallel to line PQ. Okay? All right, let's go on to angles, something you've been working with for a number of years. Angles are formed when two lines meet at a vertex. Now, they can be two lines, two line segments, or two rays. It doesn't matter. As long as those structures meet at a vertex, an angle is formed. Okay, so again, from the Geometer Sketchpad unit, we've been working with angles, hundreds of angles over the years. So let's draw a simple diagram. Okay, so I've got an example of an angle here. Angle ABC, and you'll notice in my diagram that I've kind of reinforced or made the vertex a little bit bigger so that it stands out. This is the vertex. Very important to know what a vertex is, especially if you're using Geometer Sketchpad. Okay? Now, from grade 6, probably from grade 5, you remembered and memorized how to label angles. Very simple once you get the hang of it. So this is angle ABC, or you can also call it angle CBA. So you'll notice, okay, that you always have to notice that the vertex point B, right here, point B, is always the middle letter. Angle ABC or angle CBA, they are the same angle. Okay? All right. So let's build on what we know, what we understand about angles, and talk about angle families. So let's go on to adjacent angles. Adjacent angles are two angles that share a side and are next to each other. So adjacent angles are two angles that share a side and are next to each other. Okay, so what do you think that will look like? Okay, so here's a diagram of two adjacent angles. So as you're drawing them, you notice that you've got two angles side by side. You've got angle RST and you've got angle TSU. And you'll notice that these two angles share one side. This side is called ST. These are adjacent angles. Adjacent angles, not just in the world of geometry and math, but the word adjacent means side by side, next to each other. So it just makes sense that these are called adjacent angles. Okay, so let's write down what we know here. Well, we know that angle RST and angle TSU are adjacent angles. Okay, and I'm just going to highlight one thing. They are adjacent because they share this line segment here, ST. Okay? Angle RST and angle TSU are adjacent angles. Okay, let's move on to the next one. Complementary angles. So if you finish the Geometer Sketchpad unit, you have some introduction to complementary angles. They are two or more adjacent angles that add up to, and this is very important, they add up to 90 degrees. Okay, so that's very important. That's one of those magic numbers in geometry. Complementary angles, two or more adjacent angles that add up to 90 degrees. Okay, so let's draw a diagram of that. Okay, so here is a diagram of a complementary angles, two complementary angles in fact. So when you're drawing it, make sure you draw the right angle first. So the right angle here is HIK, HIK or KIH. And then we know it's a 90-degree angle because we've got that perpendicular symbol in there, that 90 degree. Then we're going to draw this line, which is called the bisector, to cut this angle into two. One of the angles measures 30 degrees. One of the angles measures 60 degrees. Now, if we do mental math, 60 degrees plus 30 degrees is 90 degrees. And it should be 90 degrees because those two angles fit inside a right angle. Okay, so let's make a little note here. So, angle HIJ and angle JIK equals, well, angle HIJ right here equals 30 degrees, and angle JIK is 60 degrees, and if we add those up, they have a sum of 90 degrees. Therefore, angle HIJ and angle JIK are complementary. It's hard for me to fit that in the box. Okay. So because those two angles add up to 90 degrees, they are called complementary angles. So if I were to ask you, well, if one of the angles is 60 degrees, what is its complement? Well, its complement is 30 degrees. And if I gave you 30 degrees and I asked what would its complement be, 30 degrees, its complement would be 60 degrees. Okay? All right, so if you understand complementary angles, then supplementary angles are quite similar but different. All right, supplementary angles. Two or more adjacent angles that add up to, and this time it's a different sum. It's not 90 degrees because that was the definition for complementary angles. It would be 180 degrees. Okay? So again, if you finish the Geometer Sketchpad unit, you've had some experience with these. So what does that diagram look like? All right, so for this diagram, I've drawn three angles that make up the supplementary angle family. So first, you need to start with a straight line. Straight line is angle RST. Now you know that a straight angle has a measurement of 180 degrees. Angle RST is a straight line, so it has a measurement of 180 degrees. Then what we do is we chop it into three separate angles here. We have angle RSU, which is 50 degrees. We have angle USV, which is 70 degrees. And we have angle VST, which is 60 degrees. So if you add those up, 50 plus 70 is 120. 120 plus 60 is 180. So make sure you draw the diagram very carefully. Okay, so I'm going to have to write really small here to get this in. All right, so we're going to follow a similar method up here. So let's go angle RSU and angle USV, angle USV, and angle VST. Okay, so angle RSU is this, angle USV is this, and angle VST is this. Okay, equals. So angle RSU is 50 degrees, that's its measurement. Angle VSU is 70 degrees. Angle VST is 60 degrees. And if you add all of those up, they equal 180 degrees. Therefore, we're going to have room. Angle RSU and angle USV and angle VST are supplementary. Okay? So because these three angles add up to 180 degrees, they are called supplementary angles. Okay? They are not called straight angles. Remember, a straight angle is one angle that measures exactly 180 degrees. So a lot of students get confused between straight angles and supplementary angles. They are two completely different things. Okay, so we're on the last one. Vertical angles or opposite angles. So they are angles across or opposite an intersection from each other. Angles across or opposite an intersection from each other. Okay, so what does that diagram look like? Okay, so we have two line segments. We have line CD and line AB, and they crisscross. They cross each other. And when they cross each other, they form an intersection point called E. Now, angles that are across from each other at an intersection are called vertical angles. And one other rule that you need to know is that their measurement is exactly the same. Okay? So angle CEA, which is this angle right here, CEA, and angle BED, angle BED, angle BED are vertical angles. Okay? Now remember, vertical or opposite, those two terms are interchangeable. So we could have written angle CEA and angle BED are opposite angles. But there's also another pair of opposite angles. Can you see them? So I'm going to highlight them here. This angle here and this angle here are opposite as well. Okay? Because they look across each other at an intersection. So let's add those to our notes as well. So they are angle CEB. Let's see, angle CEB, angle, oops. Let's try that again. Sorry. Angle CEB and angle AED are also vertical angles. Okay, so at an intersection, there's always going to be at least two pairs of vertical or opposite angles. Okay, so this concludes part 2 of this video tutorial on geometric concepts. Thanks for watching. Bye.